this hour. We're going to be visiting a carbon star in Pisces. Talk about a faint cluster, a star cluster that's leaking, let's say, in space. It's a fascinating story. Where Mars is against the core of the galaxy, out to the asteroid belt for the dwarf planet Ceres, and wait till you see the green flash on Venus. I guess we got that picture stowed away. Gentlemen, let's meet you, shall we? President of the club, 3 years running, Jerry Wilson. Hello, Jerry. Good morning.
I think that's 4 years now.
Yeah.
Wow. Oh, my God. But
who's counting?
well, shouldn't we have had an online vote? I mean,
I tried.
Should have had an online coup.
I think we're living the big lie. That's on the national station. Anyway, Pat Forgy doing all right? Your wife? She visited you on the... Well, maybe she'll show up. Chuck
well,
McCartney.
right now she's out walking the community. She's
okay.
On exercise.
Yeah, I like the board meetings because Chuck has Pat, our merchandise manager, sitting next to him. Chuck McPartland, outreaching like crazy, even during the pandemic. Tom Totten's running the show. Top of the screen here where I am, webmaster, technical wizard, former president. And also Tom Whittemore is on board.
Morning.
Former Westmont College science instructor. Baker par excellent. Is that the word? God, I miss your. I'd love to have a nice slice of that freshly baked sourdough bread with some butter on it. Gentlemen, let's look at the sillies before we go to that incredible picture of Venus. If you can call it up, we got the following forwarded science humor cartoons from President Jerry to look at. Start the hour off with a little humor. A telescope first with Galileo. Another, the astronaut in space, but get Galileo ready. And then the unknown, Stephen Hawking's arrives in heaven. Here it is. Galileo's in his exile tower, looking out the window at the night sky. One of the priests dunks his head into a door and says, "Hey, discovered anything new tonight, Galileo?" And he says, "Yeah, the Queen has a tattoo." Not really clear, gentlemen, whether SBAU wants those kind of telescope watchers in our club, but that's all right. It's a great one. I assume those are from the pages of either Telescope or Astronomy Magazine, Sky and Telescope.
No.
That where you get them?
They're from a website on Facebook called Astronomy Cartoons.
I got a feeling people like Tim Crawford love these cartoons. Call up the astronaut in space.
Oh, Ron, I want to ask you, Ron, did Italy have a king and queen at that point, or were they all these little fiefdoms or
little principalities? I think
that was under when the Vatican had more political control and had territory of its own.
Well, they took over from the Moors or the Muslims in 1492.
That's Spain.
Yeah.
Oh, that's okay. We're looking at Italy, aren't we? I'm sorry. You're absolutely right.
Yeah.
This is academic outfits here, not monks.
So there might not have been a queen in Italy. Yeah, Italy was just a bunch of city-states back then, I think.
Yeah.
Yeah, I think they should have changed the queen to the Pope.
Yeah.
Yeah.
I might be risky there.
Okay, call up the cartoon. That title gets thrown on a lot of sillies. The astronaut has gone EVA. You know, I'm sure that's what that's called when they put them outside, but what does EVA stand for?
Extravehicular activity.
It is extravehicular. All right, it's interesting. But he's shown looking through the cockpit window at the keys in the spaceship. They're hanging from the ignition inside. And he says, "Open the pod bay doors, Hal," which he didn't. I assume that's the deal. How do I get back in? All right. We have the unknown. Then we're going to do the kitty cats, if you can call that up. Starlink. Unknown is a world-class astrophysicist. We knew him well. No, is that the kitty cats?
I got the kitty cats for you here first.
Well,
these are cats sleeping in the receiver dish for the Starlink.
Oh, they're in the dish.
Yeah, they're in the antenna because it generates heat a little bit, and cats found it in this environment.
Okay. I thought cats were immune to all cold. They had enough hair on them, but there you go. Starlink. Where is Starlink? Does anybody know?
It's up in the sky.
This is
Oh,
the
it's up in-
Starlink is the thousands of satellites that Musk is launching up there.
Yeah. And I think he just launched another 64 about a week or two ago.
Yeah.
And there's kitty cats up there, according to this.
No,
Oh.
the receiver dishes on the Earth generate heat.
Oh,
It's in a
okay.
cold
Washington
environment.
satellites.
Okay, that's Starlink. Gotcha.
And here's,
One
here's
more.
another, here's an op-ed in Los Angeles Times, another one, January 16th, that satellites may devastate research astronomy. So he's,
Yep.
and this guy who made the article, he's getting all sorts of trolling back at him to trying to disturb him. So it's tough when you speak up. The trolls will get you, especially if they support, SpaceX.
Huh. What
Yeah,
about everybody-
Elon, as a typical crazy person, has a whole bunch of fanboys, fanatic fans.
It said that they tried to paint them dark, and then I guess the satellites overheated when they were painted dark, and then they're trying to do a shield, but that's not quite that good. So
Yeah,
So
and that
it's-
works for visual, but it doesn't work for the synoptic survey telescope.
But
the
they
infrared.
consider all those little all those little satellites he throws up there as space junk, space
Yeah.
debris. Are they working or not?
Depends on your point of view.
Yeah. When do you
And of
think you
course
need to stream YouTube from Antarctica?
And
But
of
the
course,
stream-
we're wondering if any of those satellites will break up and cause all sorts
collide,
of mess up
yeah.
there.
The
Tom,
Chinese space station already had to maneuver to avoid one of the Starlink satellites.
I see.
Is that right? It saw it coming, huh? Wow. Tom, can you call up the last cartoon and then we'll go to Venus? Unknown. No, that's not it. That's the
Well,
cats.
this was pretty. This was sent by Chuck.
Oh, I missed
think.
this one. This one disappeared from my screen. I'm losing stuff from my inbox. I remember seeing this. What's
Yeah.
it say? What's
There's
the head?
nothing.
It's called One Small Mistake.
Oh, I see. You sent that in, Chuck.
Yeah.
And if you look,
This is a painting by Chris Butler, who came and spoke at our club once, and it's called One Small Mistake. He hates it because it's the most popular of his paintings, but it's
that's a little alien hand that got stepped on by one of our.
no, that's a keychain.
Oh, it's
Yeah.
a keychain.
A bunch of
well, that's-
keys.
It's the keys to the lunar module.
Yeah.
Oh, okay. Well, see, it needs some explanation because that looks like a little bony hand to me. Sorry, stuck in the sand there. We've seen cartoons like that. Here it is, world-class astrophysicist arriving in heaven. This would be Stephen Hawking's, and he gets to meet with St. Peter, or maybe God himself, who says, I'm sorry, Stephen, but I don't know who came or what came before the Big Bang myself either. Well, there you have it. God doesn't know. He wasn't around, perhaps. Got it. Listen, you want to go to the green flash on Venus?
Oh, yeah, let's do that.
It vacated my inbox and went somewhere. And
Have you got the link to that, Tom, or should I fire it up?
I got it.
Okay.
a green flash. Now, this can't be the same kind of green flash we saw
Yes.
pictures of.
It's
It is
exactly
the
the same
same
thing,
thing.
Ron.
It's on Venus.
Except no, it's on the Earth. Instead of the sun setting, it's Venus setting.
Wow.
Venus
It's not
is
on
setting,
Venus. That is the planet Venus, Ron.
okay, and it's setting below our horizon and makes a green flash.
Yes.
You can see
Oh.
it there. It's going, the atmosphere is splitting the light into its spectrum colors, spectral colors.
Did this
And-
come
and this
from
would-
Bruce?
This would only happen at sunset, sunrise.
Yes.
Generally,
In this case, sunset.
or Venus set.
Yeah.
And it's the same concept, the same physics going on, light.
Yeah. It's our
Yep.
atmosphere.
Same as rainbows. But that's
This-
done by water instead of air.
Bruce Murdoch is not with us, but he had commented on email. Let's talk about this, and he's not there to talk. Did he supply this to us? Where did we get this picture?
No, I sent it in.
Oh, you sent it in. Okay. So it's obviously on this side of the sun because we're looking at a crescent and it sets. Okay. Sets at night or in the morning? Where is it these days?
It's in the
star
morning
or
sky
night?
now.
Yeah.
It's the morning sky. Well, we don't have anything about Venus among our talking points, nor do we have a comet. But we've got a carbon star, and we got Mars. If you guys don't mind, can we do one thing early enough that we can get it out of the way? Because I'm sure you guys have been following the implementation, putting into place in Lagrange Point 2, our incredible James Webb Telescope. What's the status? Has it arrived yet at its
No.
point? Okay, it's almost there.
It's halfway there.
Halfway there. I
It's
saw
actually
It's 80% there.
Okay.
or 90,
80%.
92% distance wise.
Plus or minus
Time-wise.
50%, yeah.
Time wise, 23 out of 29 days.
Mm.
And it's pushing the mirrors away from their locks, I guess. They were locked in 12.5 millimeters, and they're about 3 millimeters from being free to move around the way they should. I think that's what they're trying to say.
Yeah, they're fine tuning everything. They're getting to the point where they'll start making it into one surface and testing the optics. So they'll be taking some pictures to true in the mirror here soon. But the first actual science pictures won't be received on Earth, I heard, until around May or June.
So it's going to be at the Lagrange point, but it's going to kind of corkscrew around, kind of like the helix. It's orbit around the Earth, or it won't orbit around the Earth, will it? It'll stay in place.
It's orbiting around L2.
Yeah,
Oh, okay. Orbiting around L2. That's
it's
interesting.
flying in formation with the Earth, so it doesn't go around the Earth.
But
Yeah,
L2,
L2 moves with the Earth, Ron, and then the spacecraft will be orbiting around L2.
so L2, a point in space that's approximately 1 million miles out there, has sort of a gravity of its own.
Yes.
It has a vector sum of the gravity of the Earth and the Sun, and they're equal at that point. They make equal contributions.
Well, I swear one of the graphics we saw, the moving graphics, showed it looked like it was moving around the Earth in like a peanut shape. It
No.
would dip in. We're just
No,
talking
that
about.
was the Earth moving around the Sun. That didn't show just the
Oh.
L2 going around the Earth.
Okay,
That showed the L2 going around the Sun with the Earth.
I got you. Anybody know how fast it's going? Because everything I kept seeing showed it less than a mile a second.
That display that Tom had up showed the speed.
Well, it didn't seem like it was going that fast. That's why it's
No.
taken almost a month.
Well, it's been
That keeps-
gradually decelerating. I mean, it's going fast relative to your automobile.
But see, I remember the Apollo astronauts getting to the moon, which is a quarter of that distance, in 4 days. 3
Yeah.
days. So they were, and escape velocity, the space shuttle reached what, 6-7 miles a second?
Mhm.
This did or didn't reach
This
that?
did initially to get out of the Earth's gravity field a little bit, but
Yeah,
now it's slowing down.
it's going uphill away from the Earth, and it's slowing it down as it goes up in terms of distance from the Earth.
Okay. And it's got enough fuel on board to jockey that sucker in position forever? What are we looking
Oh, yeah.
at here? What is this?
I don't know. I just clicked on it and they're just talking. It's a news update.
Oh,
So nothing worth watching there.
well, it could be if you could get us the sound. You never know. Okay, well, it'll be.
Just one other thing before we launch off into the talks. We mentioned the cell phone astronomy. And Jurgen's been doing cell phone astronomy, and he's got some nice pictures of the moon.
Mhm.
With his iPhone?
So, is it all right if I share screen here?
Yeah, sure.
Who is this?
Oh,
Jurgen.
let's see.
Jurgen.
It's not letting me while you're on, Tom. Oh, here we go. Okay. So
Jurgen.
here's Jurgen's picture of the full moon.
Using an
Almost
iPhone?
full.
Using an iPhone or a cell phone? Wow.
The cell phone, yeah. And then here's
It's a good picture.
let's see. Let's stop share on that one. And here it is. Oops. Wait, is that the same one again?
No,
Okay, it is showing the close up.
Yeah, the Apennines.
Yeah.
Chuck, is that from his 13-inch?
I don't know what scope he was using, but I bet he was using the biggest one he could. Yeah.
Yeah, 13. Yeah. Looks like the Apennines there, huh?
Yeah.
Looks like last week's craters we were zeroing in on.
Yes. Uh-huh.
It's pretty nice. That's pretty.
So just for folks who are wondering, how easy that was and how well it works, this is the kind of results you can get. So
Nice.
okay.
I also might want to welcome aboard, I hope she's watching, Tessa Flanagan, whose claim to fame was a tall walking sun in one of our past Santa Barbara solstice parades. Just learned when our SBAU online board meetings are, second Saturday. Hopefully she'll join us next month. And even before that, Friday, February 4th, 7:30, we're going to have 3 speakers. 2 of them are on the screen right now. Chrissy Cook will talk about the Kids Astronomy Club. And then 4 weeks later, exactly March 4th, we'll have a guest speaker. It's all online, and I guess SBAU.org gives people the information on how to join us. We're still not sure how we're going to do it, a webinar or Zoom or YouTube or all of the above.
It's going to be Zoom, Ron, either way, but there's a version of Zoom called Zoom Webinar.
Okay, I'm hearing somebody's phone ring. You want to answer that? So we got the green flash. Shall we go out gently, gentlemen, from Mars to Ceres to the carbon star to the faint cluster? Can we just do it that way?
Sure, whatever you want.
Jumping around. Thank you, my friend. Talking points. Mars is against the core of the galaxy. Does that mean it's going to get lost in giant clouds of dust? Last weeks of the month, for the next couple of weeks, 22 January. Early risers only. Mars will skim beneath an open star cluster, NGC 6469, on its way to M20, the Trifid cluster, as well as the Lagoon, M8, Lagoon Nebula.
This region of the sky is the stuff that's up in the evening in the summer. But now you can, this time of year, we're 6 months out, you can see it in the early morning sky. It's extremely rich in spectacular images or objects that you can reach with amateur telescopes. There's a lot of NGCs here, circles with crosses in it, which are globular clusters. And then the dotted circle is an open cluster, and the square in this diagram is a nebula. M20, M8 is the Lagoon Nebula. M20 is the Trifid Nebula, roughly into 3 parts. All of them spectacular objects and easy to photograph. They're easy to photograph with a cell phone too, if you have a telescope to look through, and you have some way of adjusting the tracking speed. So this is it's a wonderful part of the sky. Sometimes I set up and just look at it, and I don't even look for an object. I just look in roughly the area because I've looked at it so many times. I know where everything is. It's great to show for us at outreach, especially at the Ritz-Carlton, because we're looking out over the ocean in the south toward this set of constellations, and the objects are very dramatic if the sky is clear. And out over the ocean, you get very, very low light pollution. Very dark sky.
Well, now, Jerry and the rest of you, that big angled cigar that we all know as the edge of the Milky Way, which is at an angle in the sky, does it go from house to house in the zodiac? Would it be in a certain one right now?
Ron, no.
It doesn't. Is it the ecliptic across it?
No, the galaxy has a different plane than the ecliptic in the solar system. We're tipped at about 60 degrees difference from the galactic plane.
Right.
But the ecliptic goes across the galaxy. That's what you're seeing here, pretty much where the path of Mars is, because the ecliptic is where the planets appear in the sky.
Okay, but it seems to go at an angle from north to south.
Yeah, that's the plane of the galaxy that kind of suggested by this picture. Of course, I know it's there, so maybe I'm seeing it for that reason. But imagine a line tipping from bottom right to upper left at about 60 degrees to the path of Mars. And that's the galactic plane.
And right now, the galactic plane is kind of almost east to west.
Yeah. So right now, we're coming up on one of my favorite parts of the year is the, actually, I like every part of the year, but we're looking out at the north polar axis of the galaxy, and we're looking at galactic clusters. like Virgo cluster.
Yeah, that's kind of more spring unless you stay up pretty late.
Yeah, it's going to, in March, it's going to be that way, but we're coming up on it.
Yeah.
Yeah.
Well, we're going to be talking about a fascinating faint cluster called Palomar 5 later on. Mars is on our side or the other side of the sun?
Other side.
Other side. So
Almost as far away from us as you can get. It gets close every 2 years, and now it's got about a year to go.
I got you. The Trifid and the Lagoon, they're nebula. They're not star clusters.
They're the M8 is a lagoon and a star cluster.
They're okay. Wow. Why do they call it the Lagoon, you suppose?
I have no idea where some of these names came from.
It's called the Lagoon Nebula because if you look in an eyepiece, at least at the nebulosity, there seems to be a dark area in the middle of it, and that's a lagoon.
Well, I got to tell you, M20, which is the Trifid, is one of my favorite horror movies from the 50s. Day of the Trifids, the live plants that eat people, the hollyhocks. Anyway, Mars. Ophiuchus is mentioned, but there you go. Shall we go on out to Ceres now, gentlemen? Since we're eating up time, we're almost to the halfway point. Ceres is a dwarf planet. There's only a couple of them in the belt, right?
There's only one in the asteroid belt.
Yeah.
This is it, the Ceres?
Yep.
Yep.
What's the one that starts with V?
Vesta.
Vesta?
That's an asteroid. And then there's Varuna, which is a trans-Neptunian object.
Yeah.
Oh, okay. Well,
Ceres is spherical.
Right.
And so it's a dwarf planet under the current definition.
Yeah, it's 600 miles across, and it's just south of the Pleiades, which is M45 after
Currently,
dark.
right. It's turning the corner going from prograde to retrograde motion.
Okay.
Or the other way, I forget.
Yeah,
But
it's going retrograde to prograde.
Okay.
Can you find it most nights when you're doing your occulting, Chuck? Can you lock on
Well,
the
I don't.
Ceres?
Well, that part of the sky has to be up where it is, but
Yeah,
yeah,
right.
it would be easy to spot. I don't usually look for it, but
Does it have to be on our side of the sun?
that helps, but it doesn't have to be.
Well, if it's on the opposite side, the sun in the middle, you're certainly not going to see it.
Yeah, in the daytime, it would be a lot harder to see.
Does it ever get used in occulting stars?
Yeah. Oh, sure.
I'll bet it really blocks them out.
Yeah.
Here we are, the 4 largest asteroids. Oh, Vesta is not a dwarf planet, is it? I'll be darned. Pallas?
Mhm.
Well, they're
Idea.
still arguing about the dwarf planet definition. So
Is there a number that's a minimum that'll make something totally spherical? 300, 400 miles?
depends what you're
depends on-
made out of.
Yes.
Depends on what it's made of.
Yep. And how strong it is.
Well, we've heard some of this.
Ceres is believed to be a large component of Ceres is water.
Water.
So that may help it, but it will be, I guess it's speculated to even be liquid underneath the surface.
There's a comparison to the moon.
Yeah.
Moon's about 3 or 4 times its diameter. As we've talked about before, you could superimpose the moon over most of the United States, couldn't you? At least the bottom 48. Wow, fascinating stuff. It says here in your talk notes, Jerry, and I wanted you to explain this. After 5 p.m. or at 5 p.m., which is it's starting to get dark, Ceres is stationary. But after dark in Taurus, less than 6 degrees south of the Pleiades. What does that mean, stationary? It's got to be moving all the time, doesn't it?
Well, it is moving, but we're moving faster than it. And so at some point we overtake it, and it appears to be, because we're moving ahead of it, it appears to move backwards.
Got it.
So it appears to come to a stop and then back up, and then it comes to a stop and then it speeds up and goes forward again from our point of view. But
Okay.
it doesn't, it just continues around in its ellipse and we continue in our ellipse.
And it's in my birth sign, Taurus.
Uh-huh.
What are the stars 13 and 14 Tauri? Do you know what those are?
They're
That's how to
stars.
find it.
Tauri.
Tauri?
Yeah, they're
Taurus.
stars.
Okay, both magnitude 6. Ceres will be the next brightest dot in your field of view, slightly south of both of them.
Those are stars that partially make up the constellation of Taurus, or are at least within the borders of the constellation of Taurus.
Taurus the bull.
Taurus the bull. Here. This is a good. Tom got a good map here. You can see 13 and 14 Tauri in Ceres here.
Oh, there it is. Wow. Huh. Does anybody remember that Twilight Zone where the guy was sentenced to stay on an asteroid and they had to fire a rocket and land it there and give him supplies? Do you remember that?
Yeah, he fell in love with his robot. He wouldn't leave it behind.
Yeah, that's
I'm
right.
not sure. Perhaps. I just know there was a rocket landing and there was air and he was breathing and it was out. Everything was sunny and
That
warm.
was when I was in high school. And the amazing thing about that asteroid is it had an Earth pressure atmosphere.
Yes, everything amazing about that.
Yeah, I knew that was wrong.
Even back then, I'd shake my head and said, no, not on an asteroid. I'm sorry. Fascinating stuff. And it's my sign. I'm Ferdinand the Bull. Shall we go? Here's another one I've never heard of, gentlemen. A red carbon star, deep red in Pisces. What the heck is going on? What is it, on its way to becoming producing iron and collapsing? It's
No.
Not
ballooned up.
necessarily.
Yeah.
Well, carbon is what, 6?
Mm-hmm.
Okay. So it's got a way to go. It's called 19 Piscium or TX Piscium. It's in its final stages of life. And doggone, the moon is bright, so I guess you wait till it sets or something.
No, this should power through the moon.
Oh, it should? Okay. And you look to Pisces, and apparently this is puffed up into a cool red giant. Carbon scatters blue and green light, so only the red wavelengths shine through. Find 19 PSC. Wow.
Yeah.
Is this it?
And Ron, the fact that it's TX Piscium tells me that it is a variable star. Okay, so I'll bet you this thing has a cycle time of upwards of a year, maybe. Don't know it personally, but I'm sure it's a variable.
Yeah,
Very
it goes
good.
from 4.9 to 5.5 magnitude.
Okay.
Okay. It's also a C-type star. What does that mean?
It's a carbon.
A carbon.
Classic carbon star.
Carbon.
Mm-hmm.
And
it's,
there are lots of these in the sky, and they get intensely red. But if
Yes.
they're variable and they're in the brighter part of their phase, they don't look as red because they kind of saturate the red sensors in your eye and they start to look kind of yellowish orange. But when they're dim, they look intensely red.
Yeah.
Because they're cool, they're actually forming molecules in their atmosphere.
Mm-hmm.
The carbon star has produced more carbon than oxygen, and the carbon combines with oxygen in the star's atmosphere, uses up all the oxygen and forms carbon monoxide, and then it has carbon left over, which is used to form other carbon compounds such as cyanogen, silicon carbide, and hydrogen carbide, CH.
Yeah. Silicon carbide's dear to my heart.
Silicon carbide, yeah, that's what we use for grinding.
And dear to Jerry's heart too, I'm sure.
Yeah.
What did I miss on that? What's silicon carbide?
It's our grit, the
grit that we use to grind mirrors.
Yeah.
Oh, okay, gotcha.
So these are an asymptotic giant branch star. It's a luminous red giant. The atmosphere contains more carbon than oxygen, and the oxygen is quickly used up. The two elements combined in the upper layers of the star forming carbon monoxide, which I said, and leaves carbon atoms free to form other compounds, which gives the star a sooty atmosphere and a striking ruby red appearance. There's also, less common, there are also dwarf and supergiant carbon stars, but the most common by far is the classic carbon star, which is what this is an example of.
That might be a good outreach star. That could make a good outreach star given the time of the year and everything.
Yeah, Artleporus actually looks better, and that's good at this time of year.
Mm-hmm.
Okay.
And Herschel's garnet star, that's a beauty. Mm-hmm.
Yeah.
And
Tim Crawford loves that one.
Yeah, Musephi, Tim has a heart, a warm spot in his heart for that one.
Yeah.
And carbon being the basis of life on our planet, it combines with things far more than most elements, doesn't it?
It gives a rich array of organic molecules.
That's what organic means, right? It's got carbon in it.
Yeah.
Yeah.
Mm-hmm.
CH?
Yeah, there's
what is-
Arloporus. I just see that there, Chuck.
Yeah.
Arloporus. Yeah, we show that one a lot. There's TX Pecium.
So what is
And
CH?
those are within range of, smaller telescopes,
Yeah.
Very nice.
Wow. Ruby red in appearance. Who would have thought?
Mhm. Very beautiful, Ron.
I know, but carbon to me connotes sooty, brown, black, not red.
Well, just think when the sky is full of soot, what kind of sunsets you get.
Oh,
Right.
yeah, you're
Hey,
absolutely
look at
right.
that. We got a chart.
What does that mean? Oh, cherry red.
That's pretty cute.
Our sun has a fair share, but it's not a carbon star, right? 'Cause
Right.
certainly
No. No, these are gigantic stars, Ron.
Our sun is an oxygen-rich star
Well, thank God for that.
as opposed to carbon-rich.
Yeah.
Wow.
And much too hot.
Yeah. Now, what he's got up there now is a Hertzsprung-Russell diagram.
Mhm.
And this was started back in the 1800s when the women at I forget, they're called computers at Harvard College Observatory,
Mhm.
noticed that the temperature of the star matched the color of the star. And so they had this chemical classification. Has someone got something on it?
Not me.
Okay. So the color classification and spectral class versus temperature, and that started this main branch, which is it goes from upper left to lower right.
Yep.
And those are the spectral classes are across the top,
Mhm.
and it goes. It's "Oh, be a fine girl, kiss me" was the thing I learned in high school. I guess that's not PC anymore, but. And then the temperatures are on the, looks like it's on the right. No?
Yeah.
It's on the left. Magnitude on the right, luminosity on the left, which sort of, you can see the temperatures on the top also, but it's under the spectral letters.
Oh, yeah, there it is. Yeah.
Right. And
Okay.
if you guys just want to show where the sun comes in, look at the one on the left and see where it crosses roughly the G on the top in that flutter of yellow. So
Yeah.
that's where our sun is. It's a G25 star.
Yeah. It's where one and G cross.
Right.
We're right. Yeah. Good
Yeah.
point.
There.
And this diagram, you can look at it and you can tell it's showing a wide variety of stars. Because if you only classify young stars, they tend to lie along the main sequence, which is that diagonal line.
Right.
But as they age, they go off into red giants, and you start to see that blob that's to the left of the diagonal line.
Mhm.
And then they go up into super giants, up top, and then they blow up or poof off their outer layers, and they drop down to become white dwarfs, which are very old.
Which is a coasting star.
Yeah.
The other thing, a lot of things leave the main sequence because they are in a double star or multiple star system, and they start sharing mass with each other, and that changes the dynamics of the mass to lifestyle, you might say, or life cycle function. And so they form their own spur off the main sequence from other processes, including those. I was planning a more detailed discussion of the Hertzsprung-Russell diagram for next week.
That'd be good. That'd be good. Yeah. It's
So that we have the picture of the VX Andromeda Star, the one that we talked about in the talking points, how you would expect to see it in a wide field telescopic view.
Well, we have a picture of the VX Andromedae, but we were talking about Pisceum, but it's
Oh,
a
that's
similar
right,
kind
yeah.
of star.
Pisces.
Yeah, same type of star, right?
yeah, the fishes, Ron.
Are there a lot of carbon stars out
Yeah.
there?
Fishes,
Oh
Ron?
yeah. Yeah, they are. Yeah.
And they're all reddish.
Yeah, just typically
Yes.
look like this.
Well, here is something, if I could explain it, that I don't quite understand. You say the temperature of a star. I have heard that our sun is got a certain temperature inside.
Mhm.
It suddenly goes through the roof when it gets to the corona. The corona is really hot. So
Right.
what do
Go
We're talking
ahead.
about the photosphere.
Right.
it's like 10 million degrees or something
No.
like that?
No,
Yeah,
about
it's just the
13,000.
10,000
Well-
degrees.
So where I used to work, that was a thing under study. So the solar corona goes up around 1 or 2 million kelvins. And it was a mystery when I was at the Lockheed Labs. I don't think it is anymore. Chuck, do you know?
Yeah, I
Or
think,
Jerry?
yeah, it's like these mini flares that are happening constantly on the surface.
Yeah. Yeah, I always thought it was like magnetic field pumping,
Yeah,
which would be a result of a flare for sure.
yeah. Yeah,
Well,
see, you can see in this Hertzsprung-Russell diagram, the sun is about 6,000 Kelvin, somewhere between 5 and 6.
Mhm.
Yeah,
And,
and the
and
core of
that's
the
the
sun.
photosphere. That's the main light producing region of the sun.
That's
And that's
what-
how you classify the temperature. It's the outside of the star.
That's what we see.
Yeah. And above that, the atmosphere reaches 1 to 2 or 3 million degrees. And the core has to be over 10 million degrees in order
Right.
to initiate fusion.
Right. I was going to mention that to Ron. So the core of the sun is ballpark 13 million kelvins. And so you can get fusion in there. You get fusion inside
Yeah.
to create helium.
Okay, we're back to this again. There's different reds. Cherry red. Oh, there we go. What is Betelgeuse? It's not a carbon, is it? It's
Yes, it is.
Oh,
it
yeah.
is.
It's enormous.
I know it's ready to go anytime. So,
Yeah.
but it's
Its outer layers extend out to the orbit of Jupiter if it was where our sun was.
Bruce Murdoch has joined us. Hello, Bruce. Thank you for getting
Hello.
on board.
It took me a half an hour to get on for some reason.
You need a Mac.
Well, maybe you've been sitting in the little room. Never mind. We're not going to go there. But
I abhor Macintosh and Apple computers. I won't use them.
okay,
My
You missed-
condolences.
you missed the green flash from Venus earlier. You wanted to talk about that.
Yeah, I saw that. In fact, I answered that. It really shows the layering in our atmosphere because
Yeah.
it keeps going over and over and over again.
Who would have thought? Man, oh man, what do we got now? A brown screen? What are we
Yeah.
looking at?
This is a
There it
Venus
is.
green flash, Ron.
Oh, we're getting it again for Bruce's benefit. Thank you. Okay,
Somebody
that-
must have had pretty good tracking on their scope to be able to keep that in view, because that's got to be pretty high power.
Yeah.
it's
Well,
just-
the crescent of Venus is actually quite large.
Mhm.
but it's just
It's,
a moment.
it's not moon size though.
No, no,
Is
no.
it?
Oh, no.
But it's the green is a momentary flash, just like it is on our sunsets.
Yes.
It
Mhm.
didn't take long. In other words, it doesn't stay there for several minutes.
But there's a lot of layers in the atmosphere, and each time which have different come on, what's the word? Indices of refraction. So when it goes from one to the other, you keep getting this diffusion of the dispersion, I should say, of the colors. So you get the green flash, and then it goes red again. When it goes to the next layer, you get the green flash, etc.
But now we wouldn't get that on a little dinky Mercury because it doesn't have an atmosphere, or does that atmosphere have anything to do with it? Venus has an
I-
atmosphere.
I think it's our atmosphere.
Oh.
Our
Really?
atmosphere diffracts light differently versus color. Reds are diffracted the least, and greens next, blue the most.
Wow.
And
Did
the
get
blue
this
is
on
scattered,
Mercury?
so you don't see it. And the last thing you see is the green. And that's
Yep.
a function of our atmosphere, not a function of what we're looking at.
Yeah, you
Right.
can see that on Mercury. You also see it on Sirius. That's why Sirius often looks like it's flashing colors.
Sirius, the star?
Yeah,
It also scintillates a whole lot.
yeah.
A star called Sirius has a green flash. Wow. Fascinating
Well,
stuff.
Okay, it's not a
Well-
green flash like this where it's setting, but you'll see it flash colors because of the same kind of atmospheric dispersion.
Right.
Okay. Well, we've touched on the carbon stars. Shall we go to a faint cluster and talk about Palomar at some point? Or are we still back on carbon or us? I'm looking at these combined, I guess, compounds that you put on the line there, Jerry. CH would be carbon and hydrogen. What is that known as?
Yeah.
That's just different forms of gas and oil. And
No, they're just carbon compounds, like ammonia or something.
oh, okay.
Tickle the nose.
CN is cyanogen.
Yeah. And silicon carbide is SiC2.
Oh, okay, SiC2, and then C3 is what? That's 3 carbon atoms
That's 3
together.
carbons. Yeah, it's just soot.
Wow, really likes to bond with things. Okay, shall we go out
Yeah,
way out in
diamond
space,
C4.
gentlemen? For large scopes, there's a faint cluster out there, and it's a globular called Palomar 5. Also at one time called Serpens. I'm not sure if that's Serpens.
No.
Serpens is the constellation
The
it's in.
constellation. Here's
There
Oh.
should be a number there, but I lifted that paragraph from Astronomy Magazine, and apparently they left the number out. So
Okay, well, Palomar 5 is a blob of stars, just 7 arc minutes wide. You might see it early in the morning between the moon setting and twilight. You're going to need a good scope, a good view of the southeast horizon to find one softly glowing prize, Palomar 5.
yeah. Now the picture between 2 red stars shows a very faint collection of stars,
right.
and this is the remnant of a globular cluster that is currently streaming away. It's compared to M5, which is another much easier and brighter and spectacular globular cluster. Now, in this case of M5, the mutual attraction, mutual gravitation is stronger than the difference in orbits that are created by moving around the Milky Way. Remember, these globular clusters all move in a big spherical shell in different planes around the galaxy, around our galaxy. But each star in them is being tugged by tidal forces to leave the star cluster. That is, the star cluster would break up. But one like M5 has enough mutual attraction to hold the star cluster together. And a lot of these have black holes in them, which help keep them together too. The Palomar 5 is a different story. This is the end game. This one does not have enough mutual attraction between its members to keep it together. And so it's streaming and losing stars as it goes by. So the part of the cluster that is farthest away from the galaxy core of the Milky Way would be leaving stars in a trailing cluster or a stream out of the top of the cluster, and the bottom of the cluster would be losing them out of a faster orbiting stream at the bottom of the cluster. And there's an illustration I sent just before we went on the air that shows a stream, an illustration, not a photograph, of a stream just recently discovered around the Milky Way that shows, it's a graphic of the stream that's from a globular cluster like this one.
Is the globular cluster the thing that's about in diameter half the distance between the 2 red stars?
Yes,
Oh, yeah.
that's the globular cluster. That's what's left of it.
It's not that one little bright point there, Bruce. It's actually that cloud of stars.
Right.
Yeah, that's what I say. The diameter of the cloud of stars is about equal to half the distance between the 2 red stars.
Yeah, you're
Or
right.
maybe even more. Yeah.
Well, give or take.
Yeah.
Yeah.
Okay, but it's got a stream how long? 30,000 light years?
Yeah.
Wow.
And there's like 5,000 stars in that stream?
Yes.
5,000 solar masses. It could be many more
Yeah,
stars.
that's right.
Oh, okay. And I missed sort of the gist of what's causing that. Does it have something to do with the fact that it's close to the interior, or?
No.
It's
Go ahead.
no, you go ahead.
It's tidal forces. Okay, pulling on it. Just
Right.
like you get tidal bulges on the Earth, on both sides of the Earth relative to the moon, you get these stars affected on both sides of the globular cluster, and they stream out of it. They get pulled
Right.
out of it by the tidal forces.
Would you find most globular clusters inside the arms of the galaxy, or
No.
can they be out here in a little
No, they're
No.
mostly in the halo.
Mhm.
in the halo?
They're like the Oort cloud for our galaxy.
Oh, you mean they're
Good
out?
way.
Yeah. And this globular cluster is inside of its Roche limit, an analogy to planets being torn apart.
Wow. Okay, but this is a different one, and it's hard to see. Have any of you ever focused on it?
I've never looked at it before.
What, Palomar 5?
Yeah, Palomar 5. I didn't hear about it until I found it this week.
Yeah.
On the internet, not in the sky.
The only
It's been very cloudy here.
The only Palomar object I've ever looked at is the Intergalactic Wanderer, I guess it is. The,
Oh, yeah.
Mm-hmm.
What's that?
That's another globular that's really like 300,000 light years out.
Right, right. I remember showing that at Westmont
Yeah.
some years ago.
Jerry mentioned M5. What is M5 the same as Palomar 5? M5?
No.
No, it's
No,
Messier
no,
5.
no.
What is
It's a beautiful globular cluster, Ron.
It's
spectacular.
Messier 5, Ron.
I sent a picture of it. The
It's in
core.
Serpent's the Serpent.
But they don't. It's not a common thing that they both have the number 5 in them.
No,
That's
No, not at all.
coincidence.
And
that's
So
just
I'm
an
going
accident.
to mention something about this imp, not that one, the previous
we
one,
lose
Tom? The one of Palomar 5?
Yeah, that's Palomar
What
5.
happened? Right there. So there's
Yeah.
Palomar 5 in there in between the two red stars. So
Yeah.
if you look, this clearly was taken by a pretty large optic. If you look in the distance, you can see galaxies way, 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 way out there. Okay, kind of all over the place.
Huh.
So that was imaged by some pretty large optic.
Uh-huh.
Yeah.
And they had some pretty clear atmosphere too.
Yeah.
Yeah, there's
Yeah.
some nice galaxies down there. And so
That's
you
from
can
the
see
Sloan
right through the
Digital Sky
globular cluster.
Survey.
Jerry, you got
Yeah.
buried there. Say it again. You can see.
Oh, I said you can see right through the globular cluster.
Right. And
It's
those
not real dense.
Those galaxies are very far away compared to where that Palomar 5 is.
Well, do you suppose it'll ever lose all its stars and cease being a globular cluster?
Pretty close to that now.
Oh, it
Mhm.
is. Wow. What are the two bright stars at the upper right and lower left? What are those?
Stars and serpents.
Yeah, some stars and serpents.
They have nothing to do with the globular.
Right.
Is one of them Mu serpents? Or
I don't know.
I don't know.
I don't know about that.
These would
It
be
has
pretty
nothing to do
dim
with-
stars.
It has nothing to do with the big snake
Yeah,
constellation.
Yes,
this-
it's in serpents.
Yes, this is the
Okay.
serpent held by Ophiuchus.
That's the largest constellation there is, isn't it? The
No,
snake-
that's Hydra, Ron. That's Hydra, the sea serpent. This
Yeah.
is part of the serpent being held by Ophiuchus.
Right, right.
Ophiuchus.
Which is a summertime thing,
Yeah.
at star parties.
Someday we're
This
going
is,
to
I
have to go
believe,
into
serpent's
Ophi.
caput. So the
Mhm.
serpents is actually in two parts: his head and his tail, and this is in the head
Right.
part.
Right, the caput.
Well, we're talking about it, but how many of you have seen it? Have you actually locked in on what we're looking at
M5,
here?
well, M5.
M5 all
Look
the
at all the
time.
time.
Yeah, that's a very
M5
popular.
rivals M.
And
That's a
it's-
very
M5
popular
rivals
object for
M13
outreach.
viewing wise.
what were you saying, Bruce?
I said M5 it rivals M13 viewing wise.
That's it. So good old Messier, he nailed anything big up there. It could be a star, it could be a cluster, it could be a nebula.
Well, he was looking for comets, remember?
Oh, okay, and he named a lot of comets, and they're
And
just
he
all-
didn't have a very good telescope, so clusters kind of looked like comets. They were fuzzy and indistinct.
Right.
And he found them through his scope or just by his sight of his naked eye,
Through his scope.
through his scope.
Borrowed some from other people's catalogs too. I don't know if he found them through his scope too.
Yeah. He had
Well,
You
some-
also have to remember back in the day that he was looking at these things, they didn't have all this light pollution we have now.
Yeah,
Well, it turns out, I just read an article about this, and it turns out Paris was now starting to light itself, of course, not with electrical lights, but rather, candles and things like that.
And gas lights, right?
Yeah.
and they had a lot of smoke that they had to deal with.
That's true too. And that whole philosophy moved to London, and it's a sad story how we all lost our skies, and only a handful of people, around the world have seen the Milky Way. You know, it's too bad.
Wow, yeah.
Yeah.
Well,
Now,
Right.
right.
The next time you're in Chicago, try to see anything in the night sky.
oh, there we are.
Top of the Sears
Let's-
building.
That's M10 that you got there.
Okay, part of our 88.
Just wanted to show serpents.
Mhm.
Aha.
So
Well,
on the right
apparently
is Serpent's cap at the head, and on the left is Serpent's cauda, the tail.
Right. Mhm.
apparently it's a relatively new discovery. 1950, Walter Beatty, B-A-A-D-E.
Well, that's Palomar 5,
It's
Ron.
Palomar 5. The
That's
Vulture
what I'm
Box.
talking about. That's the faint cluster we're talking about. I guess it's because it's so faint that they didn't see it earlier. So. Galactic center starting to go flat.
Yeah, that's because it's losing stars out of the top and the bottom because of the tidal forces from the core of the galaxy.
The higher the magnitude number, the harder to see. So 11.8 is very dim, isn't it?
Need a big scope for that.
Okay.
Or a camera.
And this has nothing to
You need to know where those two red stars are.
Yeah. Right.
Where is that telescope with this name on it? Palomar. Where is that? That's on a.
In
On
Palomar.
Palomar Mountain.
Down
Here
near
in-
San Diego.
And near San Diego, Ron.
Oh, is that where it is?
Yeah.
Mhm.
So
Fascinating.
Ron, I have a comment from Jim Williams going back to the Hertzsprung-Russell diagram and the mnemonic at the top to memorize the
Mhm.
star brightnesses or temperatures. And Jim says that that OBAFGKM was a big hit of all the things I presented when I visited the schools in Sri Lanka, because he would go to Sri Lanka and visit, who's that famous?
Arthur C. Clarke.
Yeah,
Arthur
Clark.
C. Clarke.
Oh,
And so
yeah.
he says, I bet they all remember that to this day, 20 years later. So
Yeah.
he must have did a little astronomy teaching to the kids there in Sri Lanka.
Mhm.
Sri Lanka is that teardrop shaped island off the southern coast of India.
The former Ceylon.
Yeah.
That's right.
Do you
Right.
suppose they have any mountains high enough to put a observatory on, or
They have some mountains.
do they? They also have a lot of problems government-wise, don't they? Protests and military, or am I thinking of Myanmar?
It's,
Probably.
it's
Oh, no.
sort of religious and ethnic civil war problems.
Yeah, the
Okay.
Timor Tigers. Timor Tigers.
Tamil tigers.
Tamil tigers are in Sri
So
Lanka.
Chuck, what was
Ooh,
this
that's-
asteroid business here?
Oh, there's a close pass of a 1.2 kilometer, I think it is, asteroid coming up on Monday night and Tuesday night. I think we're only going to have clear weather. Oh, this is Monday. Yeah, we're only going to have clear weather tomorrow night.
Okay.
But it's visible in a 4-inch scope, and there's a nice article at Sky and Telescope where you can get these nice finder charts and you can blow them up to take a look at it. I'm going to try to video it.
Oh, wow.
I put a little article up on EdHat, and I'm going to try to get the video up on EdHat if I get it.
Is this the one the YouTube videos have been claiming may slam into the earth?
Yeah, it's going to
Massive.
miss by 1.2 million miles.
Okay, that's even further than James Webb.
It's five lunar distances.
Okay.
Wow. Okay.
Of course, we had that volcanic explosion. I think Earth, big
Oh.
events on Earth are kind of like exoplanet things that we should look for.
Yeah.
That tsunami hit here. It dirtied
Yeah.
the beaches up north of us.
Well,
Fascinating.
they had damage in Ventura Harbor too.
Wow. But it
Yeah,
didn't wipe
that
out.
was a pretty impressive satellite view.
Yeah.
Coming up out of the ocean. Who would have thought? Little Tonga is devastated. It's flat islands.
Yeah,
They don't know,
covered with ash. I mean, like crazy.
I see.
Yeah. Jeez. Of course,
Wow.
global
And
warming
it
is
cut off.
raising.
It cut off communication with Tonga, so they're worried. They got some kind of SOS signal from a ham radio operator, and they're
Oh, boy.
trying to reestablish contact.
Mhm.
Well, I watch a Japanese channel on PBS, and that's all they were talking about out of Japan was the eastern coast. Everybody was heading for high ground. Look at that.
Yeah.
Back on terra firma.
So Chuck, all those yellow indicators are islands out there, huh?
Yes, those are the outlines of the islands.
Oh, boy.
Wow.
And you
Suppose we're
can
gonna
see
get
there's
some-
one right there at the epicenter.
Yeah, I see that, but that's
That's
not
Tonga.
That is
Probably
Tonga.
not there anymore.
Yeah.
That's probably Tonga up on top there.
No, that's Fiji there where you're circling, Ron, I think,
Okay.
or Tom. And Tonga is right there. Yeah.
Oh, brother.
What do you suppose what we're looking at is a future island?
Well, it already is an island.
Mhm.
Oh, it is?
Was.
Yeah.
I thought it was undersea.
Well, it's an undersea volcano, but it's
Right.
already poked above the top.
Yeah.
Okay,
It's a
so
part of
it's
an
an
island
island.
arc. An island arc.
Take a while to get some green plants going on that sucker, won't it? It's gonna
You
stay
can see
rotten.
here's a semi photo of it here.
Oh, wow.
You can see how close Hunga Tonga is there.
Yeah.
Yeah, I think no one lived on those islands because they're part of the volcano.
Yeah.
And then they're saying, I think the center, it was the thing that really blew up this time and wiped out a lot of stuff.
But that tsunami was either 3 or 4 feet some places, 9 feet other places. You just wonder about tsunamis. What makes
Well,
them?
when you get a constriction because of the landmass, where in the open ocean, tsunami has very little height. But when it starts to come to shore and it gets compressed, then
That's
it gets
true.
in height.
Yeah, undersea the
Earthquakes.
territory, the kind of terrain you have is really going to affect how high it is when it hits.
Right.
It also depends whether there's a lot of turbidity current. It's the change in the elevation of the ocean floor that causes the
Right.
tsunami.
Yeah.
And
The second-
interaction with other currents.
Yeah, it had a second explosion even more recently, either today or yesterday, that was bigger.
I didn't know that.
Yeah, and so it's definitely in the middle of doing something with the tectonic plates out there that's in the middle of the Pacific. That's not on the rim. Guess it's active.
Well, New Zealand is part of the Ring of Fire, and this is an extension of that.
Mm.
Yeah.
Wow.
My daughter plays volleyball on the beach at Pismo. She lives up in 5 cities and complaining that there's all kinds of debris because of that damn tsunami. And I said, well, given your tsunamis, I'll take this one any day over the ones that wipe out villages and homes. And
Yeah.
we've had some bad ones in Japan, as you probably know. Fascinating stuff. Have we gone over our time limit or reached our 60 minutes, gentlemen?
I think we're getting
What?
close.
Yep, we went out into space.
2 minutes.
Yep, clear out to a faint cluster and back home to Earth. Star Trek cats of the USS.
It's clear we're running out of time when you see stuff like that.
Notice I had to get rid of my cat. I was allergic to the poor thing. It used to climb on my shoulder. You're
Oh,
lucky.
yeah. Beautiful
rest-
cat.
Yeah, I liked it. Sorry about that. Well, shall we
We'll
do
get
this
you-
again on a week away? And gentlemen, it'll be number 48 next week, and that is 4 days or 4 Mondays away from a year.
Mhm.
And once again, Mr. President, Jerry and Chuck, you're prepared for about 20 minutes each on the night of the 4th of February, right?
Yes. Yeah.
Yeah.
And we're going to put that together on SBAU.org as far as what the membership does.
Whatever Tom is going to set up.
I'm sure he's awesome. And the museum is closed until this weekend. Maybe it'll reopen again, and we'll gather in our dens and man caves next Monday morning. Give my love to your wives. Stay safe. And I appreciate it. Thank you very much on behalf of the SBAU Astro Hour and Santa Barbara Astronomical Unit. I'm Baron. Say goodbye.
Thanks,
And we'll see you
everybody.
next week.
Thanks
Bye.
very
Out of here.
Thanks,
Take
Tom.
care.